Say hello to Maya. She's the owner of a construction coating company that does projects of roofing, wall coatings, and waterproofing across different regions, seasons, and temperature. Maya collects data for customer satisfaction rating on a scale of 1 to 10, gauging the workmanship quality for these projects. She has a data set of 2,414 cases distributed amongst different regions, namely South, West, Midwest, Northeast, and different seasons summer, fall, spring, and winter. Now, Maya is wondering with this data set if she can predict using one or a combination of the different predictors that what could be the customer satisfaction rating in different scenarios. For this, we need to develop a prediction model. What is a prediction model? It is a tool that takes input in the form of data like what Maya has with multiple parameters and giving us an outcome predicting the likelihood of the customer being satisfied with a yes or a no. This is where our research begins. Prediction models can be developed using traditional statistical methods or modern machine learning algorithms. The statistical world requires the data to follow a certain kind of distribution, comply with a checklist of assumptions, and then undergo transformations to make sure there is no bias in the dataset. However, our dataset is unbalanced, which is why we had to look at the other side of the world, which was machine learning, where the dataset could have a complex relationship between the different variables, multiple dimensions, will go through pre-processing to take care of the bias, will have a division between the testing and the training to validate the prediction model. The challenge here is that as a researcher, I am lost because there is no guide to help me through this. It would be wonderful if there is a decision-making framework that could help me or a future researcher navigate through this maze of framework for developing a prediction model. So how did we do this? We first measured the outcomes. That is, we input the data in both the statistical prediction model and the machine learning prediction model, and we compared these outcomes, documenting the advantages and limitations for both the approaches. In this process, we also develop an extensively comprehensive list, wealth of information, which we call as the filtration gates for our data sets in both these approaches. Now, this is the repository which contains all the parameters critical for designing a prediction model, which then becomes a tool to navigate through this maze. In the initial analysis, we then developed a conceptual quadrant that was mapping all the methods from both the statistical side and the machine learning side on the x-axis from traditional to modern and the y-axis from regular to advanced. The findings were specifically interesting because the statistical world found that the South region and the spring season were most favorable for higher customer satisfaction ratings, while the machine learning approach gave us exact factors for each of these predictors with an accuracy of up to 92 to 95%. This makes Maya a more prepared owner of the construction coding company, making her customer, that is the facility manager or the owner or the end user, very happy because she can now strategize job sites and work plans, and he can select vendors more appropriately.